Hello, my beautiful pre-calc students. This video is for you, and it is on the law of sines. I think that you are working on the law of sines right now because my tutors tell me you are. So I wanted to do a video on this because what I want to do for you today is actually derive the law of sines. I want to show you where it comes from. You probably just memorized it, but we're all about deriving our formulas here at Alexander Tutoring. We like to know where things come from because that's what where all the interesting nuggets are, if you ask me. So let's do it, and you can all totally do it. So here's the law of sines. You probably memorized that in class. Cool thing about the law of sines as compared to the SOHCAHTOA that you're used to is that the law of sines applies to any triangle, whereas SOHCAHTOA only applies to right triangles. Okay, so I'm going to show you where this guy comes from. So the way we're going to do that is we're going to take this triangle. Oh, first of all, let's make sure we know what our symbols mean. The capital A, B, and C, these guys, those are to represent the three angles in the triangle. And the lowercase a, b, and c, those are to represent the sides of the triangle, the length of the sides right across from their corresponding angle. So angle A is here. And then if you go straight across the triangle from the angle A, right, straight across, you end up at side A. So that's how that works. So in order to derive the law of sines, what we're going to do is we're going to make an altitude here. What an altitude is, so we're just going to take a line and drop it straight down so it makes a right triangle with the bottom here, the side A. We're going to call that height h. That's an altitude, technically speaking. Okay, so now what we have, you'll notice we have two right triangles, and that will allow us to apply the SOHCAHTOA that you're used to. So I'm going to apply it first on the triangle on the left, and just applying good old SOHCAHTOA, which I hope you're familiar with by now, we can say that the sine of the angle B is equal to, sine is opposite over hypotenuse, so that's so of SOHCAHTOA. So the opposite side is h, in this case, the height, altitude h, over the hypotenuse of the triangle on the left here. Again, I'm looking at this triangle. The hypotenuse is c, the side c. So we can say this, right? Okay, and then we're just going to do the exact same thing with the triangle on the right, this triangle here, and we're going to do the same thing again. So we can, I'm going to use the angle C now. So we can say that the sine of the angle C equals opposite of the angle is h again, over hypotenuse. In this case, the hypotenuse of the triangle on the right is the side B. And there we go. We have two equations. And you'll notice that they both have h in common. So I can solve for h. I'm going to multiply this guy by c on both sides to get h equals c sine the angle B. I'm going to multiply this guy by b on both sides to get h equals b times the sine the angle C. And you can see these are both equal to the same height h, so we can set them equal to each other. C sine B equals b sine C. Now to get these looking a little more like our law of sines, I'm going to divide both sides by the sine of B and the sine of C. I'll show you what I mean by that. Sine B sine C. Same thing on the other side. Sine B sine C. This is just a little bookkeeping to so this cancels to make it look a little more like what we're going for, and then we get C over sine C equals B over sine B. We're close, right? This looks a lot like the law of sines. We got this part of it here. Boop. Now, we just need that sine A over A part, so all we got to do is basically repeat this same process with a different altitude. So what I'm going to do is erase this guy. And I'm going to draw a new altitude. This time, I'm going to do it this way. Boom. Okay, so we're going to call that another h. And then we are going to just basically do it again, and we should get there. So we need a this time, right? So what I'm going to do is use the triangle on the left, this triangle over here. Okay, and we're just going to do it again. So I'm going to do the sine of a this time because we need a in there. Sine angle a equals opposite. In this case, should we go opposite is h again. Over the hypotenuse of that triangle is once again c. And then I'll do the triangle on the right just like we did before. I'm going to use the angle c again. So we can say that the sine of the angle c equals opposite, in this case h again, over the hypotenuse of that triangle, which is now a in this case. Cool. And then I'm going to kind of skip here again, multiplying both sides by c and over here, and both sides by a over here. I'm just going to kind of skip a step here. We can set these two guys equal to say that c sine a equals a sine c. Again, I kind of skipped a step, but we did the same thing last time. And just like the other time, we're going to divide by sine a sine c on both sides. Make it look like the law of sines. Cancel, 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 cancel. And we get a equals, a over sine a equals c over sine c. And guess what? If we combine these two guys, we can see that everybody's equal, right? Because we have a c over sine c here, and we have the same thing here, which is equal to a over sine a. So everybody's equal to each other, so we can set them all equal to each other to get a over sine a equals b over sine b equals c over sine c. There it is, folks. That is how you properly derive an equation. You can see really what we did is just use SOHCAHTOA. We chopped a triangle that could be any triangle up into multiple triangles using, just by drawing an altitude. We use SOHCAHTOA on those two right triangles, and that's all there is to it. That gives you the law of sines. The cool thing about the law of sines is it applies to any triangle. Awesome. Thanks for paying attention. I hope you're doing well in this part of the class. I'll show you how to use the law of sines next time. Okay, have a great one. Take care.